Testing, testing.
Testing, testing.
Oh, hello everyone. Can everyone hear me? Testing. Now, if you can hear me, could you type a 1 in the chat? Oh, nice. Thank you. Yep, I can see we have 3 participants in the chat room, 4. We still have about 3 minutes before we're going to start. I can see some very familiar name in the live chat. How's everyone thinking about the difficulty of today's exam? Do you feel like it's easier than usual, or it's more difficult than all the previous tests? Hopefully it's easier. No? Okay. Yeah, I can see someone saying okay, fine. That's a good sign. Oh, easier than usual. Nice, good for you. Wait, what does that supposed to mean? 32 out of 50. Is that how you would rank the difficulty? Oh, so that's what it means. The difficulty is 64%. Nice. Let me just adjust my laptop just a little bit right before we start. Okay, so now it's 7:30 p.m. So today we are going to look at some tough questions from this NMOS review lesson. Of course, we don't have time to go through all 30 questions, and especially, to be honest, I think the difficulty of this year's NMOS might be one of the easiest throughout all the previous years, because they really state about this during their briefing that they are going to reduce the difficulty for this year, and eventually they did. So the first question that we are going to look at, before we start, I'm going to give you all the answers to all 30 questions at the end of this lesson. So make sure you stay until the very end to get all the answers, all 30 questions. Okay, all good? So let us have a look at the first question of the day, which is question 9. So we have Mary and Alice are sisters. Mary has twice as much savings as Alice, and they decided to buy a table for the bedroom they share, and 10% of Mary's savings and 4% of Alice's savings are used to buy this table, which cost 120. Oh, that's a very expensive table, I must say. And how much in dollars does Mary have in savings now? Well, let us try to first extract some useful information from this question. Now, we know that the ratio of the money for Mary to Alice is 2U to 1U. So that's something we know for sure. Now, what's another thing we know? Well, after that, it says that 10% of Mary's savings, which is 0.1 times 2U, the saving of Mary, and 4% of Alice, so that's plus 0.04 times 1U. And then when they combine these two quantities, they will get $120, which is the cost of the table. 120. Now, who can tell me how do I get just 1U? So what is 1U over here? Very good. That would be $500. Okay, so on the left hand side we have 2.4U, 0.24U, and then that will correspond to $120. So 1U is $500. Now, the question asks, how much, now be careful, in dollars does Mary have in savings now? So if I take this 2U, 2 times 500, I will get $1,000. But is that the amount that Mary has now? That is not, because he spent some money. And how much did he spend? 10%. Okay, so what is the amount that Mary has now? That would be 1,000 minus 100, which is the amount that she spends. So we get 900. So the final answer should be 900. So make sure that you read the question carefully, because many students come to me and say, teacher, I missed the last part. And they write the final answer as 1,000 and not 900. Okay, I hope you all didn't fall into this trap. Now, moving on, let us have a look at the next question. Now, I'm constantly looking at the chat, see if you have any other questions. Now, moving on, we have question 12. Now, Mr. Liu plans to distribute sweets to his students. So we have Xavier, very cool name, Yu Meng, Y, and Zaini, Z, in the ratio of 3 to 5 to 6. However, he made a mistake when passing out the sweets. The 3 students ended up receiving the sweets in the ratio of 2 to 3 to 5 instead. If one of the students received 10 more sweets than planned, how many sweets did Xavier receive from Mr. Liu? Now, we see that this is a changing ratio problem. Now, if you were in my class or if you joined Cui Lao's webinar a few days ago, he especially emphasized that changing ratio problem is one of Emil's favorite. And here we go, we have a changing ratio problem. And how do we tackle a changing ratio problem? It's always the same technique. We find the invariant quantity. So what is the invariant quantity here? Let's see. So at the beginning, we have some amount of sweets by Mr. Liu, and then he's going to distribute this amount of sweets to the 3 students. Now, would it matter how much each of them gets? Would the total amount change? The answer is no. So in this case, the invariant quantity here is the total amount. Now let's have a look. On the top, we have 3 to 5 to 6. And if we add up 3 and 5 and 6 units, we will get 14. And then on the bottom, we have 2 plus 3 plus 5, we have 10. So we see that the sum, at least for now, are not the same. One is 14 and one is 10. But we know the sum must be the same. So how can we change, how can we unify the units over here so that the sum become the same? Well, we could multiply. Let me bring up my eraser. Let me just quickly erase this. we can multiply the first ratio with 5 and the ratio below with 7. And what would this give us? Let's check. So now we know that in order for their sum to be the same, the ratio must become, so for the top, this would become 15, 25, and 30. And then for the bottom, we would have 14, 21, and 35. So now let's check if the sum is the same. The sum here is 70, and the sum here is also 70. Which makes sense because it doesn't matter who take more sweets, eventually the same amount stay the same. Now, which students get more candy? Let's see. They only say that one of the students received 10 more sweets. Now, which one? Could you type in the chat? Which one? Which one took more sweets? Now we see that from 30 to 35, there's an increase in Zai's sweets. And then here's a decrease for Yuming, and then decrease for Xavier as well. So that we know this plus 10 must go here, and then this one will be minus 1 and minus 4. So this is units. Oops, sorry, this should be 5 units. Now, we know that this student over here, the Zaini, has received 10 more sweets. And this will correspond to 10 sweets. So 5 units equal 10 sweets. And we can get 1 unit is 2 sweets. So if 1 unit is 2 sweets, how many sweets did Xavier receive from Mr. Liu at the very end? So that would be this amount over here. So if 1 unit is 2, so we simply take 14 times 2, and then we get 28. Very good. I can see some correct answer in the chat. 28. So that would be your final answer of this question. And again, let me stress this. So if you have a changing ratio problem, okay, if the ratio changes throughout the question, then you always look for invariant quantity, or somehow you can call it the constant quantity. It's the same. Okay, great. I think most of you got this question correct. Now, the next question that we're going to look at is question 22. Now, why did I put question 22 here? Because we're going to use the same exact technique for this question as well. Let's see. A university encourages all faculties to strive for a higher ratio of female students to male students. And in the previous year, a certain faculty had 1,473 female students and 2,023 male students. So let me first write down that we have some female students to male students. And we know that the number of female students is 1,473, and for male students is 2,023. And to meet the target ratio of 3 to 4, new students were recruited in the ratio of 1 male, 1 female, like a couple. 1 male, 1 female, another male, another female students. As a result, the new ratio of female to male students did become 3 to 4. So now we have 3 to 4. Find the number of new students recruited. So we're going to find the change in the female students as well as the male students. Now again, we see that this is another changing ratio problem. Where the ratio again changed from this ratio to this ratio. So what technique we're going to use? What quantity we are going to be looking for? Some invariant quantity. But in this case, what is the invariant quantity? Is it still the total amount? The total number of students? No, we did come in some new students. So, but in this case, the invariant quantity here is the difference between the male students and the female students. For example, imagine this. Like if this is the male students, and this is the female students. If we add one more male, one more female, one more male, one more female, and another one more male, one more female, we see that this difference would always stay the same. So the difference here is an invariant quantity. Now let's check. At this moment, do we have the same difference? Now over here the difference is 1, and over here, what's the difference over here? That would be 1, 7. Oh, it's not 1,7,7. It's 550. Sorry, yeah, that's 550. So now, in order for the difference to be the same, what do we have to do with this ratio? What do we have to do with this ratio? I'm looking at the chat. Any suggestion? Well, we could try to modify the ratio at the bottom one. So what number should I multiply with this bottom ratio in order for the difference to be the same? It'll just be 550. So now let us multiply the bottom ratio with 550. So let me get the pen. So multiply with 550. Now that this ratio would become 3 times 550, which is 1650, to 4 times 550, and that's 2200. Now let's check. Do they have the same difference? If we take 2200 minus 1650, indeed we get 550. So now we see that the difference is the invariant quantity over here. So how many students have added? From 1650 minus 1473, we get 177. And the change in the male students will be 2200 minus 2023, and again 177. So how many new students? 177 times 2, which will give us 354. Very good. I can see some of you got the correct answer. Awesome. Okay, so again, changing ratio word problem. It's very easy. Just remember, you always look for the invariant quantity. Okay, all good. Now, let us move on to the next question, which would be question 21. Now, some students told me that this is a very hard question, a very tough one, but we're going to see that if you know just a small trick, then it will be very easy. First of all, let's see. Now, given that the smaller square of side length x, so this length over here is x, and this is a square, making more obvious, was cut from a bigger square of side length y. So that's y. The resulting figure has area of 240. Suppose x and y are both whole numbers. Now that's very important. Very important. They must be whole numbers. So no decimals over here. What is the largest possible value of y plus x? Let's see. First, let's see where would this area 240 correspond to. Now what I will do, I will first divide this shaded region into two parts. So now I get a rectangle on top. Now can someone tell me the area of this rectangle on top? Now we know that the width is y, but what is the height over here? That will be, y minus x. And for this part over here, for this rectangle at the bottom, again, we have x as the height. Now what is the width? What is the width? That is, again, y minus x. Because we know this one is y minus x, and this one is y minus x. So now, if we know that the shadow region, the total area of the shadow region is 240, now that means that these two areas over here, when added together, plus x times y minus x, this would give us 240. Now, did you notice something? We can factorize the y minus x. So if we factorize the y minus x, we will get y plus x times y minus x. You can check by multiplying y with this bracket and take x with this bracket, you get the same thing. So now we know that these two numbers over here, these two brackets over here, when multiplied together, we get 240. Now what does it mean? Let me erase some of the writing here to make it more obvious. So now we have two numbers. One number is over here, one number is over here, and when they multiply together, we will get 240. Now in order to figure out what are these two numbers, maybe the first thing we can do is that we have to look what are the factors of 240, because if they multiply together to get 240, they must be factors of 240. Now what are the factors of 240? If we do the prime factorization, we will get 2 to the power of 4 times 3 times 5. So now we know that this thing on the right hand side, this 240, can be written as 2 to the power of 4 times 3, times 5. And these two numbers on the left must be different combinations of these factors over here. Now, in order for y plus x to be as large as possible, what would be the chances? What would be some possible numbers? Well, the first thing you might think is that, oh teacher, that's very easy. We can just take 240 and 1 and bravo, we have solved this problem. The largest number for y plus x is 240. Is that it? Is that your final answer? No, there's a thing you need to remember, is that the sum and difference of two numbers must have must be even or odd. And by that I mean both. Now what does that mean? What does that mean? Imagine if you have two numbers x and y. Now if I have x plus y, I will get either an even number or an odd number. And let's say that if x plus y is even, then is it possible that x minus y is odd? Think about it. Does that make sense? X plus y is even, but x minus y is odd. That can't be true, right? If two numbers are both even number minus even number, then of course we're going to get an even number. Or if I tell you that x plus y is odd, then x minus y would also be odd. So if you have two numbers, the sum and the difference must be either both even or both odd. And in this case, we see that 240 is an even number and 1 is an odd number. Now this is a big hint that this is not the numbers that we're looking for. So instead, let me slightly reduce the value for x plus y, which in this case, it could be 1, 2, 0, and 2. Now can you tell me, we have an even number and an even number over here. Now, would that be possible? Yes. And we know that this would be the maximum number that y plus x can get. So the final answer would be just 1, 2, 0. Okay. Now I believe most of you guys would have gotten over here. But if I have put the final answer as 240, that's a shame. That's so pity. Okay. Remember that if x plus y is even, x minus y is also even. And if x plus y is odd, then x minus y would also be odd. That's something worth remembering. Okay? Oh, good. Did you guys got this question correct? Could you type a 1 in the chat if you got this question correct? I just want to see how many of you got this question correct. Oh, nice. Wait, what does 2 supposed to mean? 2 means no. You forgot your answer? You forgot your answer, that's okay. Okay, so the final answer for this one will be 120. Now let us move on to some more difficult questions, which would be question 23. So let's have a look. The whole numbers 1 through 16 are to be placed in the 16 squares below. One number per square, so you can't put 2 numbers in the square. Makes sense, right? And the sum of the numbers in each row and column is the same. Find the largest possible sum of the 4 numbers in the corner squares. So then if I call this A, this B, this C, and D, we're trying to find the maximum possible sum of A plus B plus C plus D. How do I approach this question? Well, for all this kind of grid problem, I'll call it a grid problem whenever you move columns, rows, and diagonals, and we're talking about the sum. At least the first thing that you can do is you always can find the sum of all the squares over here. So we have 1 to 16, so I can sum up from 1 to 2 to 3, ... all the way to 16 to first find out what is the sum of these 16 numbers. And then for this, let me show you a quick trick in case you haven't learned this before. We take the head plus the tail times the numbers that are in this sequence divided by 2 to get that the sum is 136. So that's the sum of all these 16 numbers. But don't forget about these 4 corners over here. How many times would they have been counted in order to find the sum of all the squares over here? It would be 136 plus A plus B plus C plus D, because they have to be counted twice. For example, this column and this column, we see that they overlap at this corner A here. So A must be counted twice, so as B, C, and D. Very good. Now, let me erase this first. Okay, now what's the next step? Let me bring up my pen again. Now we have found out that this is now the sum of 4 rows of 4 columns. Sum of 4 columns or rows. Okay, either columns or rows. So we know that the sum over here must be a multiple of 4. Make sense? Because it's 4 of the same thing. Remember that the sum is the same for this 4 columns or rows. So these numbers over here must be a multiple of 4. Now let's check. We know that 136 is already a multiple of 4. So what are some possible values that we can put for A, B, C, and D? And don't forget that we want the maximum sum. So naturally, right, if you want to get the maximum sum of A, B, C, and D, we're going to take those 4 biggest numbers. What are the 4 biggest numbers? That will be 16 plus 15 plus 14 plus 13. Now what is the sum of this? This would be, let's see, I can see in the chat some answers. Let me have a look. 16, 15, 13, yeah, let me do this step by step. So now we get 58. But let's check, remember that this is already a multiple of 4, so that we know that these 4 numbers, the sum of these 4 numbers here, must also be a multiple of 4. But is 58 a multiple of 4? Could you check for me? Could you check? The answer is no. So this is not a multiple of 4. Very good, thank you. I can see a lot of answers in the chat. But this is not a multiple of 4. So what do we do? We still want the largest sum, right? We still want the sum to be as big as possible. But I can't put 16, 15, 14, and 13 over here, which will give me 58. So we can try to reduce it a little bit so that it will become a multiple of 4. So how can I reduce some numbers over here so that I still get the largest possible numbers? I could reduce this 13 to 11. Thank you. Yes, I can see a lot of answers in the chat. Thank you. Thank you. So we can have 16 plus 15 plus 14 plus 11. And now we get 56, which is a multiple of 4. Happy times. Right. So now we know that if we have 16, 15, 14, and 11, the sum would be a multiple of 4, which makes sense. So let me erase them. So we can have 16 over here, maybe 14, and 14, and 11. So now that satisfies this equation, okay? And the next thing we're going to do is that we're just trying to fill in all the numbers in this grid so that the sum of the 4 numbers would be the same. And you can check that for yourself. Indeed, you can do different arrangement, and eventually you're going to find that all 4 columns and rows will get the same sum. So check that this would be your final answer. So the answer for this question is just 56. Now let me quickly go through this whole thinking process again. Now starting off, we have a grid which consists of 16 squares. And for all these kind of grid problems, the problem is that there are too many choices for you. There are too many options, too many possibilities, and you will have nowhere to start. But for all these grid problems, this one thing that you can always find is the sum. Let me change the color. The sum over here. And by sum, it doesn't mean that the sum just from 1 to 16. I mean the sum of all the columns and all the rows. So don't forget that there will be some overlapping parts. Okay, now why do we look for the sum? Because if you find the sum, it's going to give you some more restrictions in order to help you eliminate some possibilities, because without this you have to do a lot of trying and errors in order to get the correct answer. But for this, we can quickly narrow down that this case is not possible. So in order to satisfy this condition over here, we must have these 4 numbers. So the last thing that we have to do is just to check if this would be possible to construct. And in this case, we find that yes. So that's how you solve grid problems in general. Okay, so that's question 23. Now, let us have a look at the next question, which would be 25, question 25. Now, the number of digits required to print the page numbers of a book is twice the number of pages in the book. Oh, that's very interesting. Now, assuming that each page of the book is labeled with a page number. Also, of course, now why would I get a book where each page would label with 2 numbers? Doesn't make sense. What is the total number of pages in the book? So, any idea how to solve this problem? Again, let us start with the information given by the question first. We know that the number of digits required to print the page numbers of a book is twice the number of pages in the book. Now, to make it more obvious, let me call the number of book pages. So let me denote the number of pages as n, probably. So I'll call it as n. Now, if the page number of this book only has single digits, what would that look like? So I'll only have a book labeled from the number 1 to 9. Now, would that be possible? Would that be possible? In this case, we see that the total number of digits would just be n if we have n pages, right? So if we not exactly have 1 to 9, if we have n pages. So let me get again my pen. So number of pages is n. So for single digits, we have just n. Now carry on. What would happen if we have the page number to a 2-digit number? So if we have until double-digit pages, what will be the total number of digits? What will be the total number of digits? Well, we could have 9 digits for the first 9 single digits, 1 to 9, plus 2 times n minus 9. Right, because we take n minus the first 9 pages with just single digits, and then since they are all 2-digit number, I will have to multiply with this 2 over here. Now again, let's check. Would this equal to 2n, which is what the question is telling us? Do you think we will get 2n over here? Of course no, because we have 9 plus 2n minus 18. How would this be 2n? That's not possible. So this shows us that the number of pages of this book cannot be just 2-digit number. It must contain some 3-digit number. Okay? So carry on. Let's see. What if we have some 3-digit pages? What if we have some 3-digit pages? What's the total number of digits? Again, we'll have the first 9 pages with single digits plus 3 times n minus 99, the number of digits of those pages with 3 digits, right? So 3 times n minus 99, and don't forget about those pages with 2-digit number. We would just be 2 times 90, because we have 90 2-digit number and then multiply with 2 because they are all 2 digits. And now we have 2n. Now, is it possible to solve for n in this case? Is it possible to solve for n? Will someone tell me what is n over here? Can someone find this for me? What is n? Oh, thank you. I can see some answers in the chat. Very good. We can get, in this case, n would equal 108. So, we have found the answer. So, because we have so less information about the number of pages of this book, so we're going to do some trial and error. And we start from the easiest with. So if we have just those pages with just single digits, which is this case over here, we'll try to see if this is possible. And it turned out it is not. So we move on to the next possible case. We would be, maybe this book would have some 2 digits number of pages, and it turned out that this is also wrong. It is also not possible. And moving on, we have some pages with 3 digits. And we found out in this case, it is possible, and the number of n must be 108. So that's how you find the answer. Now, there's another way to do this. This would be a quick way, a shortcut. Imagine this, that those pages with 2-digit number, right? The total number of digits, it is going to be 2 times something. So for the numbers 10 to 99, it will be 2 times n. Of course, because they are 2-digit number. Now, but we cannot have a book that starts with page number 10. Do you have a book that starts with page number 10? The answer is no, right? The book always starts with page number 1. So here we would have some pages with some single-digit pages. It's not quite right to call it odd. From the page number 1 to page number 9. Now this is the part where it is causing us trouble, right? Because this is an odd number, and in order for the total number will be twice the number of pages. I need to find some other numbers in order to compensate for this part. So how many new pages do we have to add in order to compensate these first 9 pages? And don't forget, after 999, there will all be some 3-digit number. Now, if I have just one 3-digit pages, which will be the number 100, will that be possible? The answer is no. So we continue 108, and since we have 9 pages over here, we would also have 9 pages over here in order to compensate for the first 9 pages. So 9 pages to 108. So that's also another way to think about it. Okay, which you can choose which one you like. This one will be faster, but it takes more thinking, and then this one will be trial and error. So that's how you solve question 25. I see some of you are discussing 24 and 25 are the most difficult question in this test, but that's how you solve it. Okay. Now moving on, let us have a look at question 26. Now this is also a tough question from this NMOS 2023. We have the numbers 1 to 15 can be arranged in a sequence such that every 2 consecutive numbers add up to a square number. What is a square number, by the way? Do you know what's a square number? Can someone type some square number in the chat? What is a square number? Okay, yeah, very good. N squared, right? We can have 4, we can have 9, 16, 25, 81, right? The number times itself. Thank you. Okay, I can see a lot of square numbers. Thank you. So we know what a square number. Now the problem is, how do I arrange these 15 numbers so that every 2 of them adjacent to each other, they all add up to a square numbers? This is quite difficult, right? But let me first list out all these 15 numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, bear with me, 13, 14, and 15. Okay, so we are going to arrange these 15 numbers so that any adjacent 2 numbers would add up to a square number. Now, if you pay close attention to these 15 numbers, let me first ask you this question. Now, we know we have a lot of square numbers, right? In fact, there are infinite number of them. We have infinite numbers of square numbers. Now, would it be possible that this square number would be 81? Yes or no, chat? Yes or no? Can the sum of 2 numbers over here from 1 to 15, would it be 81, for example? Very good, thank you. I can see in the chat that the most you can get is 25, right? Because if you just take the biggest 2 numbers over here, 15 plus 14, you will only get 29. So this means that there's a restriction on the square numbers that we can get, which could be only 4, 9, 16, and 25. There's no other square numbers you can get except these 4 numbers over here. Now from here, what's the next step? Now let us pay more close attention to these 15 numbers over here. Now we know that when I add one number from these 15 numbers with another number, I could get some square numbers. For example, let us start with the first one. So 1 plus 3, that will give me square numbers. 1 plus 8, that will also give me a square number. Or I can have 1 plus 15. So that's also a square number. Oh, I can see in the chat what is a square number. A square number is basically a number multiplied by itself. For example, 2 times 2, 4. So 4 is a square number. 3 times 3, 9. So 9 is a square number. And 10 times 10, 100. 100 is also a square number. Okay? Now, so for 1, we see that 1 plus 3 square number, 1 plus 8 square number, 1 plus 15 square number. So that means that this number 1 can be placed at anywhere in these 15 numbers. Because when it adds with the number to the left, I could get a square number. When it adds to the number to the right, I will get a square number. And so as number 2, I can have 2 plus 7 to 9 and 2 plus 14. So again, this number 2 can be placed between 7 and 15 so that I will get a square number. However, if you go through this list, you will find 2 very special numbers. 2 very special numbers that can only pair up with another number, just one number, so that it will become a square number. Now, could you type in the chat to let me know which 2 are the special numbers? Which 2 numbers are the special number? Okay, I'm looking at the chat. Oh, you guys are so smart, so clever, very good. It'll be 8 and 9. Let's check. Now, in order to get a square number, now remember, these are the only 4 numbers we can get. One number must be added to the number 8. Or one number must pair up with 8 to get a square number. It can only be 1. Right, there's no other choices. In order to get 16, you have to have 8 plus 8, which will be 2 same numbers. And it's not possible to get 25. So in this case, we see that 8 can only be paired up with 1. What about 9? What would be the number paired with 9 to get a square number? Can someone type in the chat? Yes, thank you. It will be 7. Thank you. So it is only possible to get a square number with 9 and 7. So that's a very big hint over here. Now, so does that mean that I can put this number 8 at the middle of these 15 numbers? Would it be possible? Would it be possible to put this number 8 somewhere in the middle? Yes or no, chat? Yes or no? No, yes, thank you. Thank you, Keegan. Thank you, Vivian. Okay, you please. Yeah, we can't put the number 8 and 9 somewhere in the middle because they can only pair up with one number. So what does it have to do with the number on the other side? So we can only have number 8 and number 9 at the front and at the back, which is the first number and the 15th number. Okay, so we have already found the first and the 15th number. So now we only left the 8th number, which is the number at the center. So from here, we'll just start. Either way, you can start from 8 and you can start from 9. Now, which way would you think would be easier? Should we start from 8 or should we start from 9? Should we start from 8 or should we start from 9? Well, let's try, okay? If you have no idea, let's try. So for 8, we will have 8, 1, right? So 8, 1, 9, okay? Square number. And with 1, I see that, oh, now I get 2 choices, 2 options, 3 and 15. And from there, now it gets more complicated. We get 6 and 13. That's also possible. And 10, 15, I have 10. So you see that it'll get very complicated very fast. So maybe you can still get the answer, which is the case. But maybe let's try from the other way around. So starting from 9, we know the only number that can pair up with 9 is 7. And with 7 can only pair up with 9 and 2. So naturally, we know the next one must be 2. And from there, what's the next number? 2. The only possible number is 14, 11, 5, 4, and then 12. So now we get to the 8th number. 1, 2, 3, 4, 5, 6, 7, 8. So we still are starting from the number 9. It's way more easier. We have less cases to consider in order to get us to the middle number, which is number 12 here. So what is the sum of the 1st, the 8th, and the 15th number? That would be 8 plus 9 plus 12, which would give us 29. So let me quickly recap this question. Again, we have so many possibilities, so many choices, so many options. So always the first thing we can do is that we can try to come up with some ways to eliminate some possibilities. And in this case, we see that the two numbers at the front and at the back, the first number and the last number, they must pair up with just only single number so that they can get a square numbers. Because if they put what they put in the middle, then it will not be possible. It cannot pair up with another numbers. So from there, we can quickly narrow down that I can only have 8 and 9 as the first and the last number. And then the next step would be to find the middle number, which we could start from the 8. And if you go through this process, you're also going to find that this one is not possible, this one is not possible, and this one is possible. And you'll also be able to get 12. But in the exam, if you find one way is very difficult, then maybe you can try it to go another way, to take the back door, I would say, to get that, oh, this way will be much more easier. I will find 12 much more quickly. So that the final answer is 29. Okay? So I believe that's our final question of today. Now for the other questions, I've already prepared all the answers for you. So from question 1 to question 30, you can take a screenshot of all the 30 questions, of the 30 answers, and then I'm going to upload a detailed solution for all the other questions, including those questions that we have discussed today, written step-by-step solution on our forum. So if you want to get that, can I skip to the next page? Can I skip to the next slide? Yes? Okay. So in order to get, oh sorry, my laptop is lagging. So in order to get the full solution, a written step-by-step solution to all 30 questions, make sure you join our WhatsApp study group, because I will be uploading those documents to our WhatsApp group and also our forum. And we have an NMOS sprint class, okay, for special round. Now I believe many of you here are going to be get invited into the special round, right? You all are very clever, so I believe all of you will be able to get into special round. So if you want to get some help for preparing special round, we're going to have some NMOS sprint class on 8th, 15th, 2nd of July. And also, if you'd like to learn more about the course syllabus of this sprint class as well as the class schedule, make sure you join our WhatsApp study group. I will be there to help you to solve your problems, etc. Okay, so that would be it for today. Teacher Cedric, and I hope to see you soon. Okay, bye bye.